So this is the second part to my competency level assessment of representation of systems. In the first video, I focused on the differential equation and its solution, and I have the solution right over here, and if you have any questions about that from the first video, please let me know. Otherwise, for the second part of the video, we are focusing on difference equations. Now for a difference equation, the first step that you can do is actually set it equal to 0. It's I minus x to the I minus 1 equals 0. And then over here, I have a little equation sheet in the pinkish red, and it actually says that xc of n equals alpha to the nth power, which means that all these i's, like I and I minus 1, can actually become alpha to like the I. So we will change this to alpha, and then it's R5, and instead of x, it goes to alpha, and then the I goes up here. And then same thing, alpha times I minus 1 equals 0. And then we know that this is a first order difference equation, and because of this value right here, it only goes to the I minus 1 power. If it was a second order, it would go to the I minus 2, but because of this right here, we know that it is first order. So then from here, we also know that alpha to the I is actually equal to alpha times alpha to the I minus 1. We learned about that in class on Wednesday. So we will do 5 times alpha to the alpha I minus 1 minus alpha to the I minus 1 equals 0. We will divide this all by alpha times I minus 1. This will give us 5 alpha minus 1 equals 0. And we will add 1 and then divide by 5, and alpha is going to equal 1 over 5. There's all that. Which also means that x of c sub I is going to equal 1 over 5 to the I power. So I'll write these up here. I'll erase this. And now we move on to xp to the I. And this will actually equal our c2, which we are one of the variables we're trying to find, times it by this 3 to the I. Oh, sorry, I thought I had to sneeze. So we will continue, we're going to actually plug this into our original equation. So 5 times it by c2 times it by 3 to the I minus c2 times it by 3 to the I equals 3 to the I. And I minus 1 right here. And then we can divide this all by 3 to the I minus 1. And this will then give us a 5c2 times 3 minus our c2 equals 3. So right here, this is 15c2 minus c2 equals 3. So that will go to 14c2 equals 3. So divide by 14 both sides, and c2 is equal to 3 over 14. And now we have our c2, which also means that we have our xpi. So xpi will now be equal to 3 over 14 times it by that 3i. All right, so I will leave these two, c2 equals 3 over 14. I'll erase all this real quick. And now we are in the last part where xc to the n equals, we're going to do c1 times it by 1 over 5 to the I plus 3 to the 14th times by 3 to the I. Now move Wow, that's okay. All right, and we do know something actually very important. We know that at x naught, so when n equals 0 or when I equals 0, the equation's equal to 6. So this means 6 equals C1 times 1/5, and this I right here is actually becomes a 0. And then plus 3 to the 14th times by 3, and again, the I becomes 0. So then these two will become 1. So 6 equals C1 times 1 plus 3 to the 14th times it by 1. So now we have C equals C1 plus 3 to the 14th, or 3 over 14. And I'm going to grab my calculator real quick. So now we will take minus 3 over 14 over here, and minus 3 over 14 over here to get our C1. So 6 minus 3 over 14 equals 81 over 14. We will erase all this. And we have our final equation. So we have x is equal to 81 over 14 times it by, 1 over 5, I, plus 3 over 14 times it by 3 to the I. And I'll erase this and just move it in a little closer. And this is our final equation, with these values kind of being like alpha 1 and alpha 2, and then C1 and C2. That is the final solution for this difference equation up here. And if you have any questions, please let me know.